Rahim. Assalamu alaikum dear students. This is our next problem. Problem having been chosen from the same book, Modern Physics by Kenneth S. Crane. As usual, we first come to its statement. Okay. The atoms of a carbon dioxide molecule CO2 are arranged in a line with the carbon in the center and the oxygens on either side at a distance of 0.116 nanometer, nano standing for 10 to power minus 9. In the absence of vibrations, dear students, we know that rotations and vibrations are usually studied side by side, but here we are told that we have not to take into consideration vibrations. Okay, there is an absence of vibrations and we are solely concerned with rotations. Okay, hence only the rotational energy levels are under consideration. Okay, in the absence of vibrations, calculate the energies of the first 5 rotational states of carbon dioxide for rotations about an axis through the center of mass of the molecule. Dear students, we move to helping tools, and helping tools will play a lot in developing a foundation about this problem. Okay, dear students, first helping tool of this problem has been taken as a snapshot of a table of elements. Okay, a table usually given at the end of a book in appendix, in which chemical properties of elements are described, are given. Okay, dear students, this table is equally applicable to chemistry or chemical studies. Okay, anyhow, we come to helping tool number 1. Here at serial number 1, hydrogen is present. Okay, after hydrogen many other elements come, but we have taken a snapshot only of hydrogen and then carbon and then oxygen, because hydrogen is at serial at first place. So from here we can see that this number 6 is what and this number 8 is what. Okay, so data regarding hydrogen has been included just in order to ensure continuity of this table about chemical properties of elements. Okay, dear students, to the extent of carbon, we come to conclude that its atomic number is 6 and its mass number is 12. Similarly, in case of oxygen, its atomic number is 8 and its mass number is 16. Okay, dear students, how it will become clear that out of so many values, that is 10, 11, 12, 13, 14, 15, why have we chosen number 12? Okay, similarly in case of oxygen, values are from 14, 15, 16, 17, 18, 19 and 20, and out of so many values we have chosen value 16. Okay, so dear students, about these two values, some distinguishing feature must be available in this table. Okay, so what is that distinguishing feature? We come to know that in place of 12.000000, in place of abundance or half-life, 98.89% is given. Okay, 98.89% abundance is given. Similarly, in case of oxygen, whose atomic number is 8 and mass number is 16, in the place of 15.994915, 99.76% abundance is given. So this value, that is 15.99, will be rounded as 16. Okay. So dear students, from this table we can conclude that for carbon we will take the value 12, while for oxygen we will take the value 16. Okay. Now we move to next helping tool. Okay. Second helping tool number 2. In helping tool number 2, rotational energy levels of a diatomic molecule El, where L is written as a subscript of E, has been defined as being equal to L plus 1 H cut square over 2I, where L is the rotational quantum number. L has value 0, 1, 2 and so on. Okay. H cut is Planck's constant divided by 2 pi. Dear students, we know that Planck's constant is denoted by H, but here Planck's constant has been divided by 2 pi, and we know that pi, which is 22 by 7, is a very special number. Its decimal representation is non-terminating, non-repeating. It goes endlessly. Pi is a very special number. However, in normal routine, we take its value up to only 2 decimal places as 3.14. Okay, so pi, that is 22 by 7, is taken as equal to 3.14. Otherwise, its decimal representation after 14 goes endlessly. It neither repeats itself nor it terminates. Okay, it is non-repeating and non-terminating. Its decimal representation is non-terminating and non-repeating. It goes endlessly. Moreover, dear students, in the denominator of this expression, I stands for moment of inertia for axis through molecule's center of mass. Okay. Rotational energy levels of a diatomic molecule El, where L is written as a subscript of E, is equal to L into L plus 1 into H cut square over 2I, where L is a rotational quantum number and its value is from 0 to 1 to 3. Okay. Moreover, H cut is Planck's constant divided by 2 pi, and I is the moment of inertia for axis through molecule's center of mass. Helping tool number 3 is about reduced mass of a diatomic molecule. Helping tool number 3 deals with reduced mass of a diatomic molecule. So, reduced mass of a diatomic molecule is here denoted by Mr, where R is written as a subscript of M. And this reduced mass of a diatomic molecule Mr is equal to M1 M2 over M1 plus M2, where M1 is the mass of atom number 1 and M2 is the mass of atom number 2. That is, reduced mass of a diatomic molecule is equal to product of the masses of those atoms divided by addition of masses of those atoms. Okay. Now we move to helping tool number 4. Helping tool number 4 is about moment of inertia of a diatomic molecule. Okay. Moment of inertia of a diatomic molecule axis through molecule's center of mass. I is equal to Mr R naught square, where Mr is the reduced mass and R naught is the distance between centers of molecules two atoms. In this case, two atoms are atoms of oxygen. Okay. Moment of inertia of a diatomic molecule axis through molecule's center of mass I is equal to mr r naught square, where mr is reduced mass and r naught is distance between centers of molecules to atoms. Or, dear students, this helping tool has been given in two different versions. Okay, the other version is also 100% same, the only notation is different. Okay, so we can say that moment of inertia of a diatomic molecule can also be um, expressed in this alternate form, that is I is equal to m or equilibrium square. What is the difference between above and its alternate version? Okay, the only difference is that in first case we have used mr for reduced mass, and in this alternate version we have used simply m. Okay, no difference whether we use m or whether we use mr. In both cases m stands for reduced mass. Okay, this is just an approach of the author of the book. Okay, similarly in first case symbol r naught is used, which denotes distance between centers of molecules to atoms. Distance between centers of molecules to atoms, while in its alternate versions in place of r naught r equilibrium, where EQ, that is equilibrium, has been written as a subscript of capital R. Here R stands for equilibrium separation distance. Okay, so helping tool number 4 has been described in two alternate versions. Substantially there is no difference between these two versions, only notation is slightly different. Okay, so both will work. Next, tool number 5, rotational energies. Rotational energies are rotational energy levels. Okay, dear students, this tool is the most relevant tool which will solve this problem. Okay, rotational energies are rotational energy levels, EL, where L is written as a subscript of E, is equal to L plus 1 H cut square over 2m or equilibrium square, where EQ is written as a subscript of capital R, is equal to B into L plus 1. Here rotational quantum number L has values 0, 1, 2, 3 and so on. Okay, dear students, here we do not go into detail of B. Okay, because when this value is equal to this value, then definitely B will be equal to H cut square over 2m R equilibrium square. Okay, because L into L1 is also available in this, and hence B will be equal to H cut square over 2m R equilibrium square. Okay, now we move to helping tool number 6. In helping tool number 6, this table has been shown or has been adopted or has been utilized so many times in our previous problems, previous videos. Okay, from this table speed of light c will also be used in this problem. Moreover, value of Planck's constant h, which is given in two alternate units, will also be used, but this value will be divided by 2 pi, and hence h cut, instead of Planck's constant h, we will treat it as h cut or h bar or h reduced by dividing this Planck's constant h by 2 pi. Okay. Moreover, 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 value of one atomic mass unit is equal to 931.5 million electron volt over c square. This will also be used. Okay. Now we come to its solution. Okay. Solution, we know that energies of the rotational states are given as EL is equal to LL plus 1 H cut square over 2 MR equilibrium square equal to BLL plus 1, equation number 1. Okay. Dear students, this is exactly a helping tool which we have already discussed. Okay. We have become familiar with this expression. This has been described earlier in a helping tool. Okay, using now in this equation, dear students, here actually BLL plus 1, this is just a part of this expression. We will we assume that only EL is equal to LL plus 1 H cut square over 2 MR equilibrium square. Okay, we assume that B is not a part of this expression. Okay, so even if we write this expression only to this extent, our problem will not be affected. Okay, so next in this expression we will use R equilibrium equal to 0.116 nanometer, nano standing for 10 to power minus 9. From where we have taken this value is given in the problem statement. Okay, this value has been provided in the statement. Moreover, M is equal to 16U. M is equal to 16U. Actually, dear students, this M is of oxygen, because as per our previous understanding, it is written in the, yes, this is axis through molecules center of mass. So here two atoms are of oxygen, one atom is of carbon. Okay, so here again distance between centers of molecules, two atoms. Okay, r naught R capital equilibrium deals with distance between centers of molecules, two atoms. So in carbon dioxide, oxygen appears in double quantity. Okay, so here in case of mass of carbon will not be entertained. Okay, because in our expression it is described that R equilibrium is the distance between centers of molecules, two atoms. So here two atoms are of oxygen, and hence we will take M equal to 16 atomic mass unit. We will not take M equal to 12 U. 12 is for carbon while 16 is for oxygen. Okay. Moreover, H cut is equal to this 0.66 into 10 to power minus 15 electron volt into second. We get here, dear students, actually H cut is value of H cut or H bar or H reduced is not given in the table which we have used as a helping tool in this problem. Okay, the value given in that table has been divided by 2 pi, that is 3.14 multiplied by 2, that is 6.28. Okay, value of Planck's constant h given in the table has been divided by 6.28, and hence the resulting value becomes 0.66 into 10 to power minus 15 electron volt into second. Okay. So in the expression we have used this value. Okay, EL equal to L plus 1 into here h cut square divided by 2 into 16 into this. Okay, here dear students, one more thing becomes relevant to be described, that in the denominator, okay, here you can see that there is 2mr equilibrium square. There is only one 2 in the expression. Dear students, this point is very important, that the expression which we are following contains only one 2. Okay, while contains only 1 2, while in our solution portion 2 appears twice, 2 into 16u into r equilibrium square. Okay, so dear students, why this 2 has appeared twice? This 2 has appeared twice because there are 2 atoms of oxygen. Okay, 16u is the mass of oxygen. Okay, 16 atomic mass units, and carbon dioxide consists 2 atoms of oxygen. Therefore 1 2 is of formula or expression, and 1 2 is of carbon dioxide. Okay, 1 2 is for di in, and 1 2 is for appearing in the formula which we are following. Okay, anyhow, we slightly move forward and see what changes have appeared and how. So dear students, here 16 will be multiplied with 2 and 2, and hence 64. Moreover, what change we have made, we have just simplified it. Moreover, dear students, here main thing is that we will eliminate this u. Okay, atomic mass unit u, its value has been given in the table which we have introduced as a helping tool, and its value is about 931 point yes 931.5 million electron volt over c square. Okay, so anyhow, we will eliminate this u, and then because we will eliminate this u, and when we will put its value, its value will come in million electron volt over c square. Okay, so our next step will be that we will eliminate c, and we know that value of speed of light c is 2.998 into 10 to power 8 meter per second. So here we will eliminate c square and use its value. Okay, and hence mostly it is just simplification, and some steps have been merged. So I think it is not very necessary to discuss each step because some steps have been merged. Anyhow, when we simplify this expression, after putting the value of u at 1 atomic mass unit, and then putting the value of c, speed of light, and then eliminating this small n in terms of 10 to power minus 9, and then cancelling the similar units, we reach this conclusion. Okay, what conclusion? L into L plus 1 into 48.87 micro electron volt. Okay, micro means 10 to power minus 6. Okay, milli means 10 to power minus 3, micro means 10 to power minus 6, nano means 10 to power minus 9. Okay, anyhow, so this base has been developed. Okay, this is just a base for determining our states. Okay, how we will be able to determine these states? These states will be determined by putting L equal to first we will put L equal to 0, then we will put L equal to 1, then we will put L equal to 2, then we will put L equal to 3, and then we will put L equal to 4, and hence 5 states or rotational energy levels will be found. Okay, so this implies that EL is equal to this is where L is equal to 0 1 2 3 4. Okay, this is just a foundation or basic formula for us, and now we will put the value of L equal to 0, then 1, then 2, then 3, and then 4, and we will get the required energy, rotational energy levels. Okay, so when we put L equal to 0, then E naught or E0 is equal to 0. When we put L equal to 1, then E1 will become equal to 2 into this. Okay, because 1 and 1 plus 1 equal to 2, and hence it will multiply by 2, and this will become equal to this. Okay, to when multiplied with 2, it will become 96 point something at. Okay, now when we, in order to find E2, we will multiply it by 6, because 2 plus 1 3, and 3 into 2 equal to 6. We will multiply it by 6, and hence our value will become 293.22 micro electron volt. Okay, here dear students, 2 into 48.87 micro electron volt will almost become equal to 97 point something. Okay, anyhow, this is not a mistake. This is so simple, no worry. Okay, now when we will find E3, we will have to multiply it by 12, because when we will put 3 into 3 plus 1 4, 3 plus 1 4, 4 into 3 12. Okay, we will multiply it by 12, and hence value will become 586.44 micro electron volt. And when we will find E4, then 4 plus 1 5, and 5 into 4 20. That is, we will multiply it by with 20, and our resultant value will become 977.4 micro electron volt. And hence, dear students, these 5 values are the solutions of this problem. Okay, these 5: E0, E1, E2, E3, E4, and this is the end of our problem. This is the end of our video. Okay, Allah Hafiz.